And if I talk about electricity, right? So in electricity, all of you heard at least the name of resistance, right? All of you have heard this name.
Yes, sir.
Then you have heard Ohm's law. At least you must have heard, right? And many of you also know that point. Okay, I will explain the same, but I will use some synonyms and other things. Ohm's law, resistant, and these things you must have understood. Or if you know, I will add some points. Okay. So now today, like in lecture 1 of electricity, I just told you what is current. Hana? Current equal to charge by time, right? And in the in that lecture also, I had told you about voltage, potential difference, right? Potential difference equal to what?
Work by time.
Work by time. Costa, you are silent. Work by charge. Okay. Be active, guys. Hana? If anyone has not seen this lecture, you can see this in YouTube. You will go to electricity in the playlist and see the first lecture. Okay. You will get it understood. I give you guarantee. And now what I'm telling you will also get that. Hana? Hello, Nupur. Welcome. So like just a second. So yeah. So today I will discuss about Ohm's law. Okay. So how it will be easy for you to understand. All of you, for suppose Akif is here and Akif home has how many floors? Akif, you have? Medans, at you also let me know how many floors you have at home, at your home. Anyone can tell me fast. How many floors are there in your home?
So my apartment consists of 6 floors.
6 floor, okay. Others, bache, anyone other?
2, sir.
2 and
Sir,
3.
4.
Okay, fine. 4 also. So let's just take for 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 6. Okay. And you all of you know a Tanki, sister. All of you know na sister. On the
Yes, sir.
on this one. Okay. And let another whose house has 2 floors? Tell me. This one is of cost of na. This one is of cost of home, and this one is of so much time. Let it of Dev. Okay. They have 2 floors. Okay. So now what my point is like, for suppose here is also a sister. So anyone be active. Okay. Be active. And I'm asking a question. My point is, you all know that pipe will go down and for all of the floor, there will be pipe. See, for suppose I'm taking for ground floor. Here is a, here is a tap. Okay. Mansi 1, Akif 3. Okay. Good evening. Good evening. Good evening. So, and Dev has 2 floors. So pipe will be like that. Okay. So all of you can tell me, you know, that there will be difference. This one is the first floor, second, third, fourth, fifth, and sixth. Here it will be first floor and second floor. All of you can let me know in which tap the water speed is more. In this here, this one is of Kostov and this one is Dev. In which house the tap speed, water speed inside the tap will be higher? In Kostov.
house.
How? Why Kostov?
Sir, because the tank is higher. It is on the above 6th floor, and in Dev's house it is above the second floor.
Second floor. That the point is like,
It
what is the height difference?
is
Right?
more.
The point is height difference. All of you can know this thing. If you don't know, Hana, if you have 1 floor and you don't know, if you have 6, 7, 8 floors, if your tank is on the very high, Hana, on high, the water flow will be faster. Okay, that is the point. Likewise, there is a height difference in electricity. You have potential difference. What it is? Potential difference. All of you have come to know that in our household, the potential difference is 220 volt. Okay, 220 volt potential difference. What will happen if the potential difference at your home, which is coming, become 420? What will happen? Can anyone tell? All of you answer me. Be very frank and tell me. What will happen if the potential difference become 420?
So the speed will increase.
Speed of what? Potential difference I am increasing. In electricity, for suppose I am taking a battery and here is a bulb. Here the voltage is 220, right? And now I'm taking another circuit where the voltage is now 420. So what will happen? Think, all of you can think. As there is a difference of height, so water speed is increasing. What will happen if the potential difference, this voltage will increase? Lavanya?
Sir, current will increase.
Current will increase. Definitely here water flow speed is increasing, Dev. Okay. And here what will increase? The flow of the charge. Flow of the charge is increasing, means current will rapidly increase. And what will happen now? Many of your devices like pyara sa refrigerator, pyara sa like anything, can like dissume. Why? Why your appliances can be going false? It will get like get like some shock. What? Why? Current will
Because
increase.
of a large voltage passed to it.
Exactly. When the voltage increases, the current flow will also increase. All of you can understand this thing. If there will be high voltage, the current will flow very high. All of you know this thing, right now. And that thing is told by Ohm's law, by Ohm, that scientist, physicist, that he only told this thing. As the voltage will increase, the flow of the current will also, that you know, that you already know. For suppose at your home, the voltage is 90 volt only. You can see your bulb, it is like dim light, right? If the voltage at your home become 90 volt, 50 volt, right? What will happen? You will see your bulb is like just just that wire will like give light right now, and nothing more will happen. So why? Because lower is the voltage, lower will the current flow. Higher is the voltage, higher is the current flow. And this is only, you also know that when voltage will come high, all my appliances can go in false, right? So there will be MCB, miniature circuit breaker. We will discuss. Okay. So, or fuse this thing, which will save. So higher is the voltage or higher is the potential difference. Potential difference unit is, what is the unit of potential difference?
V.
Volt.
Volt only. So higher is the potential difference, higher is the current flow. All of you already know this thing. This is only the Ohm's law. Nothing new in the Ohm's law. It's just a bullshit. Very easy. Take it, means I want to take it easy now. Potential difference is volt is directly proportional to current. Now you will say that, sir, I was knowing this thing already. Now what you are going to add? Right? Right now? Now.
Yes, sir.
I'm letting you know. Okay. For suppose here is a voltage. All of you had read now. I will read voltage is directly proportional to current. So, sir, removing the directly proportional sign, I will write V equal to R into I, where R is a constant, and that is called resistance. You have learned this? All of you have heard this thing or not?
Yes,
Okay.
sir.
Sir,
Yes,
sir, I have a question.
Tell me.
So what is the difference between resistance and resistivity?
I will definitely. I know this thing. This question will come. Okay. I will have patience. Okay. I will continue this session. I will not leave in between. Okay. So right now, I will come, bacha. I will come on that. Like thing, I will take it in next lecture, definitely. Okay. So V equal to R into I. Now all of you know this thing. So what I'm going to add? Okay. All of you know about directly proportional sign, Akshat. You know about that? What is this directly proportional, Ria? Anyone?
yes,
All of you have
directly.
written in your copy. You have make notes. What exactly it is going on? So let me tell you. For suppose for a 20 volt, current in the circuit is 5 ampere. Okay, Mansi, for 20 volt, current is 5 ampere. Okay, and as directly proportional sign, teachers tells you directly proportional means what? Voltage increase, current will also increase. Voltage will go down, current will go down. So if I am taking 40 volt, what will be the current?
10 ampere.
10 ampere. How you come to know it is 10 ampere?
Sir, it
Sir,
was
because
Potential
volt
difference is
It
twice
becomes
and
double, right? All of you will tell it's double, right? It's double. Okay. And now if I remove this directly proportional sign, what will happen? 20 equal to what into 5? What will be this what? What means kya? Question. This one is question mark actually. Just I'm writing. Question mark. Into 5. As we remove the directly proportional,
Resistance.
right? Tell me.
Resistance.
I'm coming to resistance. I'm not going to resistance right now.
So it's
But
constant.
you did this na as a constant. That I'm telling what exactly why it is coming now. That we have to also know na why it is coming this constant. Why will we do rectification? 20 equal to 20 directly proportional to 5. If you remove this directly proportional sign, you are taking this equal to sign, and this equal to sign, okay, is coming. If 20 equal to 5, what you can write here which will make 20 equal to this?
4.
4. All of you can agree? I will definitely write 4 here. That become equal. If you not
Yes,
understand,
sir.
40 equal to 40 equal to what into 10? What you will write?
4.
What you? Bacha, tell me. What you will write here?
4, sir.
4 only, no?
4.
See, in both the situation, if this is directly proportional and if you want to make it equal, you need a constant which relate this equation. And this constant is not going to change. That is this R. Why then actually when we remove this directly proportional, this some constant. Why you haven't asked? Why this constant come? Lavanya, you are getting my point. Okay.
Yes, sir.
And now I remember that R is some constant. But now the next question is, what is this resistance? Okay. So for 10 point of view, at least you know that voltage, you already know, bacha. You already know this thing. Only thing it comes is R. Okay. And I told you how it connects. Voltage equal to resistance into current. Okay. Now at this point, can I write that unit of potential difference is ohm into ampere? Is it okay?
Yes, sir.
Ohm into ampere is the unit of voltage. Is it so? All of you can think
Yes,
bacha.
sir.
Definitely, now you know that potential difference unit is volt. You know this thing, but in your board exam it will be written like there will be no volt and it will be written ohm into ampere. You will think, oh, where it comes? No, see the formula itself. It is telling you very much. R into I. Okay, Ria, all of you. Now come to the next point. What I'm trying to say is resistance itself. Resistance. Okay. I talked in the last session also, but I will talk. Okay. All of you must see the lecture 1. Okay. I'm giving you guarantee you will get it understood. Okay. Everything which I told. Okay. So now my next point, resistance. All of you, there will be question from this one, right? V equal to R into I. That is not a big deal. You can do Hana from your book, V equal to R into I. Okay. If you will stuck, Hana, ask me the question. Now resistance. There are a lot of numerical questions. I will come. Now resistance. Think you have a race, right? And for suppose I am taking here Adit, okay, and here I am taking Athirat, okay, fine, Athirat, I am taking you, but I am giving you a difficult task, Athirat. What I am giving you difficult? All of you have seen this kind of like ये कुछ उठा हुआ होता है जहाँ jump करके आपको जाना होता है. You all know this thing.
Yes.
Like when you will run
Yes,
now,
sir.
for Adit now there is nothing hurdle. This is called I think hurdle, right, Nakshat? You all of know that there is some hurdle race. All of you know this or not? Hurdle race,
Yes,
बच्चा.
sir.
Where there is some like
Yes,
ऐसे
sir.
कुछ यहाँ कुछ ऐसे उठा हुआ रहता है जहाँ आपको ना अतिरथ जंप करके यहाँ then फिर आप दौड़ोगे then you will again jump. So if you both have same efficiency, who will win the race? Adit or Athirat?
Sir, Adit.
Adit. Why?
Adit.
So he
No
doesn't
Because
have
he has
Adit.
no restriction.
Exactly. He has no restriction. This is the case of superconductor in electricity. I'm telling. I'm coming on the point. This is actually superconductor and this one is the normal conductor. How exactly I'm connecting? See. This hurdle which is making Athirat speed slower than Adit because both have same efficiency. Hana, both of eaten the same things from many days, but Athirat Hana, like वो बच्चा पिछड़ जाएगा. क्यों? Because Adit has no hurdles. He will go straight and win the race, right, Adit? And but Athirat will lose the race. Why? Because I gave him hurdles. Same likewise in any conductor, in wire also. in any element, okay, you have these kind of hurdles. Now you will tell, sir, where I got don't any see hurdle in the wire? That hurdle is the name of resistance. Resistance. These resistance do what? When the charges try to flow, when the charges try to flow inside a wire, right, Ria? When charges try to flow, there are lakhs of electrons in the conductor, and when they try to flow, they collide with each other, even with the walls. Definitely it will happen, na? Okay, yes. It will happen. So definitely there is natural tendency that even a wire, even I'm telling you superconductor, it is just an imagination where the resistance is zero. Scientists are trying to develop such a wire where the resistance is zero. And that concept is taken under superconductors. Okay, but the normal conductor, even the wire, have some resistance. You all have seen resistance? You have seen some resistance in the market or not? Anyone have?
Yes, sir.
If you don't have type resistance, resistance, resistor, type this one in your on your resistor, RESISTO. You can see that in the market. Okay, resistor. Now my next point, come to, I have detailed all. So now I come to, there is some resistance, and in the last class I am telling you resistance is the inertial property of a circuit. What exactly it mean? Inertial property of circuit. What exactly it mean? Inertia is what, mama, I am sleeping and I want to wake up. You will definitely resist someone that abhi nahi uthenge. Inertial property. Koi rest mein hai, someone is sleeping and I want to make him run. It will be very difficult for him to change the state from rest to motion. And if someone is in motion, it will not get into rest suddenly. Why? There is inertia. If someone train is moving, you can't stop the train suddenly because that is inertia. So resistance is inertia property also. Suddenly you are applying voltage. Suddenly you are applying a voltage in a circuit, and you are expecting that electrons will move as you are telling. They will tell, no, we will not move. So they will move. They will definitely move as potential difference is getting applied. They will definitely move, but at least there is some resistance, hurdle is there. So that is also, that's why resistance is called inertial property of circuit. Now my next point, I have let you understood what exactly is this existence of resistance is. Okay, but the next point will be how I can determine this resistance. You must have heard this formula, resistance equal to rho into L by A. All of you have remembered this thing?
Yes, sir.
Yes.
But do you know how exactly
Yes,
this
sir.
formula works? Why is this formula only? Point is that? Getting my point? Roshni, Hiba, Arshia, R
Yes,
equal to rho into L. Can you think why? I'm telling you why. See, I'm giving an
Because
example.
it was proved by scientists, sir.
sir, to get a constant.
Tell, be frank and tell me, na. You are live. Tell me.
Sir, if we take two tubical things, sir, there is a difference in their length and area, sir. If the one is big and short, sir, and another is short and long and thin, sir. If we take their length and area, R will be directly proportional to L, and R will be inversely proportional to 1 by A, sir. So that from there they got equations.
Yeah, I got your point, Bacha. You are telling that length will be higher, then resistance will be higher. The cross-section area here cross-section area for suppose is same. Cross-section area, you know that if you cut a wire, you will get this A, cross-section area. So what I'm trying to say, for suppose there is a race. I'm getting repeated sound. So I'm taking, like I'm allowing a race here. Okay. For suppose here is a race between Udichi, Kirnika, and all of you. There are some guys who are making race. Okay. Mr. Nav, stop it. Okay. So here are some electrons you know, in real life, take a tunnel, take two tunnels. Okay, take two tunnels, and I have placed electrons here. Okay, the same number of electrons are also there. You can take it as a bike. Okay, there is a bike race. And if I allow to go, they have to come from A to B, and here from A dash to B dash. Okay, and they have to pass this AB in the shortest time, fastest speed. What will happen? There will be some accident when the electrons will go from this A place to B place, and here from A dash to B dash. What will happen? Definitely there will be some accident. As I given you, you have to move very fast, right?
Yes, sir.
Okay, so the accident will be higher where? In this 10-meter length or 5-meter length?
In length, sir.
10-meter length. Why? Why? Because see,
Longer and dimension. They are
definitely it will happen. Definitely it will happen. All of you silent yourself, bacha. I'm getting repeated sound actually from anyone of you. Just make yourself silent, okay? Your voice. So now, my point is like, if I am getting many, for suppose here are 10 bikes, and here also 10 bikes, what will happen? Some of the, here it is only 5 meters, so for suppose 2 accidents happen. And here it will might be like 5 accidents will be here. Because you have to cover fastest and with greater distance. So definitely must be there some here accident, here some accident will also happen. Some additional accident will happen here. So it means electrons collision will be larger in the length where it will be higher. So resistance is directly proportional to length. As there is the electrons have to cover longer, definitely there will be more collision. Okay. In the next class, we will discuss about this cross section area. Okay. And I will continue this resistivity point. That is the most important question. Why resistivity is constant and resistance resistivity is difference. So all of you actively participate. Okay. Yeah, I'm noticing this is voice is echoing. Actually, someone has joined the session from 2 IDs, right? I think so. Okay, guys, Hana, join your session, okay? And whatever your feedback, Hana, let me know after like 9 p.m. that thing, okay? Be like, send me your feedback, okay? If you are stuck in physics, mathematics, take the screenshot and send me, sir, I am stuck in the session. Getting my point, guys? Okay?
Yes, sir.
Yeah, all of you join your session on time, okay? We will meet again.
Bye, sir.
Thank you, sir.
Thank you, sir.
Welcome, welcome.
Thank you, sir.